Okay, just a quick video on 5.5 just so you can take some notes on and refresh if you didn't get enough in class today. 5.5 is about inequalities in one triangle. So we're going to go ahead and just jump right in. So basically if we have a triangle, then wherever the longest and shortest sides of the triangle are, has something to do with the biggest and smallest angles. And I think you're going to be able to use common sense to figure this out. So the theorem, and I don't want you to write this whole thing down, okay, just says that in a triangle, the larger angle is opposite the longer side, okay? So maybe if you want to write some notes down for this section, you write 5.5. You can write angle-side relationships in triangles as your title, and then you just need to write in a triangle, the larger angle is opposite the longer side, okay? So obviously since AB, this red line here, is longer than the blue line here, then the angle across from it, or C, is bigger than the angle across from the smaller one, or A. And of course there's a converse for that. In the triangle, the longer side is opposite the larger angle. So the angle and the side have a relationship with each other, okay? They're positions. So you're just going to be asked to write them in order from smallest to greatest. So in this picture you can see since 17.2 is the smallest, then the one across from that is the smallest, okay? And that's angle F. Since FH is the longest side, okay, because it's 20.4, obviously the one across from it is the largest angle. So if we're going to put them in order, it's F, H, then G. Angle F, comma, angle H, comma, angle G. And that's how you're going to write your answers. For the sides in order from shortest to longest, you'll notice we're missing one of the angles here, and you remember from the triangle sum theorem that we can add these up and subtract them from 180. We get 48 degrees. That means since this angle is 48, it's across from the smallest side, and since 72, which is the largest angle, is across from this side, then PR is the longest side. Okay, so we're going to write them out. PQ is the shortest, it's across from the 48. QR's the second one because it's across from 60, and PR's the longest one because it's across from 72. So we're writing the sides in order from shortest to longest. This right here is your answer. Okay, same goes with this one. If I need to write these in order from smallest to greatest, or writing the angles, obviously angle B is the smallest, angle A would be second, and angle C would be third. So your answer is angle B, comma, angle A, comma, angle C. Alright, in this example, we do have to apply some of the stuff from the previous chapter. How do you write the sides in order from shortest to longest? You're going to subtract 22 from 90 to get angle E. That gives you 68 degrees. Since angle E is 68, then we know that the side across from 22, or EF, is the shortest. The side across from the 68 is the middle one, and the side, or the hypotenuse, across from the right angle is the longest one. So our sides are in order, EF, comma, DF, comma, DE. Alright, the next thing I want to talk to you about is called the triangle inequality theorem. The triangle inequality theorem simply says that there are some lengths of segments that it is impossible to form a triangle. Okay, and you can see from this picture right here, if I had side lengths of 7, 3, and 3, these two will never touch. Okay? So what's the difference between these two? Well, you can say, well, these are longer. Well, of course, but that doesn't mean that that necessarily always forms a triangle. What you have to do is you have to follow this rule. This rule says that the sum of any two sides has to be greater than the third one. So when you're applying this theorem, you have to do an inequality 3 times. You're comparing, okay? This is the relationship. Comparing two sides added together, seeing if they are in fact greater than the third. Okay, so let's apply one of these. Can side lengths 7, 10, and 19 form a triangle? Let's start by adding 7 plus 10, the first two. When we do that, we get 17. Since 17 is not greater than the third one, 19, we don't even need to do the other two. So we're going to say no by the triangle inequality theorem. Those side lengths cannot form a triangle. Okay, 7 plus 10 is 17. 17 is not greater than 19. This next one here, we're going to start by adding these two numbers, 2.3 and 3.1. Since those make 5.4 and that's greater than the third side, we've satisfied the inequality theorem for the first relationship. Now we have to do it for the other two. So we're going to add 2.3 plus 4.6. Since we get something greater than 3.1, we say yes. And we're going to add 3 plus 1 plus 4.6. And since that gives us something greater than the third side, we say yes, and these can. Okay, just to summarize, let me walk you through one more example. This one, we only had to add the first two sides and we got something that was equal to the third side. That also cannot form a triangle, so you would say that it is not a triangle. Okay? Alright, you have some homework to do, and that's all for 5.5.